Looking at number 6, we're supposed to graph the function. We've got y equals 3x minus 1. Always a good first step is to make a table of values. So we've got x values. They tell me my inputs are going to be 1, 2, 3, 4, and 5. And the output values, if we plug in the x values that they gave us, so plug in a 1, 3 times 1 is 3, minus 1 gives me 2, 3 times 2 is 6, 6 minus 1 is 5. If we substitute a 3 in for x, 3 times 3 is 9, and 9 minus 1 gives me 8. 3 times 4 would be 12, minus 1 is 11. And you can see each time it's going up by 3, and that's because of the times 3. Now the next step is to think of these as ordered pairs. So we've got x, y coordinates. For example, we've got when we plug in 1 for x, we get 2 for y. When we plug 2 in for x, we get 5 for y. And we're going to plot these ordered pairs. We always have to move into an elevator, so we have to move left or right before we can move up or down. So we've got the point 1, 2. We'll go over 1, up 2. We've got 2, 5. So over 2, up 1, 2, 3, 4, 5. And you might notice, shoot, we're not going to be able to fit things on this graph. So this is a great example of where we might need to change the scale in order to fit our points on the graph. Our x's only go from 1 to 5, so we're not going to have any trouble fitting that. But our y's go from 2 to 14. So maybe instead of going by 1s, I'm going to go by 2s. And I can signify that by just marking the first line as a 2. And I don't have to label every single line, but just so I can keep track, I like to go every other. So I've got 2, 4, this would be 6, 8, this would be 10, there's 12, there's 14. Now if I plot the points, I've got over 1, up 2. So in this case, the scale on my y-axis is 2s. The scale on my x-axis, I'm still going by 1s. That scale doesn't have to be the same. So I got over 1, up 2. Over 2, up, there's 2, 4, up 5 would be halfway there. 3, 8. Over 3, up 2, 4, 6, 8. 4, 11. Over 4, there's 2, 4, 6, 8, 10, and then 11 would be right there. And then over 5, up 14, right there. Linear algebra is what we study this year, so it's a good little trick to use to kind of self-check if all of your dots are in a straight line, linear algebra line. We're probably good to go. And we don't connect the dots because they were specific about our domain. They said only use 1, 2, 3, 4, 5 points, so we should only have 5 points on our graph. We don't draw the lines because that signifies we could go anywhere.